I'm Goran Cvijanović, just to repeat again, principal engineer in the ReversingLabs company. And I will present you how to deal with huge amount, billions of data rows. Buzzword big data is just a buzzword. I will try to explain you a little bit what that means. What is really big data? Big data is when you have something like this. Have more than that number of records. It is 1 billion. We in ReversingLabs now have, this is a few days ago, almost 1,200, more than 100 billions of records in our database. The other criteria may be have to more than 1 terabyte of data in data set. I just take a snapshot of that storage we used for that amount of events we have. It is more than 10 terabytes of data in the database. So pretty more or less, we have big data, yes, in our system. So I will try to explain you we don't have anything, how to deal with that. Do you know how many galaxies is approximation for our universe? It is about 100 billion galaxies. So in our database, we have more than galaxies in universe approximated. So it is really impressive number. With that dots and numbers, you can be really can be fooled of, but it is a really huge number. Any one of you trying to query something and get some data from 100 billion of records, I will say in a single database or in a cluster of databases, it is a bit of challenge. So we are using only open source database. We are using open source visualization platform. Everything is open source. So I will give you links. You can try everything. You can use virtual servers. You can use Docker or whatever. And it is easy to try everything I will show you today. So how to deal with this? We need a database. In this area around, you will see a lot of famous new databases. I will say new NoSQL, SQL, key value stores, whatever you are using. It is always hard to deal with a huge amount of records in that database. I was trying to get one database which will be good for ingesting data in the database, so easy to store the data in database using different connectors or platforms, technologies, integration tools, whatever, but it should be easy to do that. It should be fast, so we can ingest, for example, I don't know, maybe 1 billion records to store. Daily frequency should be around 10, maybe more than 10 million records. It can be some frequency about, I don't know, maybe 1,000 records, 10,000 records per second, 100,000 records per second, whatever you like. And I found one database. It is ClickHouse by Yandex. It is known as Russian Google, but it is really Yandex. The link is ClickHouse Yandex. You can find a lot of information. It is very well, it is open sourced. It is on GitHub. You can download that source, compile it, and you will have your own compiled database which is running and can handle billions of records. What is Yandex ClickHouse? It is, somebody asked me, is it relational database? Yes, it have almost a full SQL 2000 SQL compatibility. So if you are familiar with SQL syntax, you can easily query that database. I will show you today, really show you, not just telling a story. It is true column-oriented database system. So what is the importance of columnar databases versus row-oriented databases? A very important thing is how to store the data. It should be stored compactly. We have billions of records. We have tens of terabytes, petabytes of data. We need something which will compactly store the data, not wasting any space in that expensive storages we are using. Should effectively process analytical queries. So we should be able to analyze our data set. So if it is not efficient enough, we should wait for minutes, hours, who knows, maybe never-ending queries which will return or maybe not return our results. So the intention is to get throughput, hundreds of millions of rows per second, because we have billions. So if it is not hundreds, multiplying something should be billions. So we need hundreds of millions of rows per second. If somebody is dealing with the databases with a huge amount of data, and then you know what I'm talking about. Data compression is also very important. Parallel processing on multiple cores. So we have some servers, we have some cores, multi-threading, a lot of functionalities of modern architectures. Database should be available able to utilize that, all the power we have. So it should be utilizing and using everything the platform should offer. So as a processing power or I/O power or whatever. The other important thing for us, but I think it is very important when you are dealing with complex data sets, is the possibility to have in a record you are thinking about, so it is some kind of representation of your data, you will always have some kind of nested subset, which is really connected to the main set you are using. So if you are thinking about relational part of that, it is some kind of master detail relation. So it will be convenient if we have some possibility to have that subset directly connected in a single data set. That's why no SQL databases are very popular. You can put something like JSON or whatever in that data set and query that, so it is easy. In ClickHouse, you have something like that. Yeah, it is nice. You have some open source database, somebody develop it, putting somewhere available, but what about a reference manual, for example, or good documentation or whatever? So it is Yandex. We are expecting something from them. There is a reference manual in Russian and English. The link is here. It's very, very good documented. All the functions in the database are documented with examples, everything. You will be amazed how some kind of open source version of the system is documented in the Russian way. I was impressed how detailed it is. They opened everything, so they're not hiding anything. They don't have separate versions, payable or whatever. They have some other business model. This database is completely free and enterprise. I was mentioned about easy to connect, easy to integrate in our systems, platforms, and whatever we need. There is 3 basic possible connections. It is HTTP interface. It can be secured also, HTTPS. JDBC driver, which is common standard with Java-based platforms. It is widely used in BI systems, and a lot of BI enterprise systems can use JDBC drivers to connect to the different databases. So if you have something like Tableau or something like that, you can connect directly using JDBC. Also, there is some browsing platforms or utilities which are using JDBC. We are using Database Beaver, commonly known, also open source tool. It can be connected directly to ClickHouse, so you can navigate using that. And there is very powerful command line client for Linux. And we are mostly using that. I will show you some examples using command line client. ClickHouse has a different type of table engines. You can use in-memory tables. You can have some log tables, very simple table stores using a file system. But the most powerful and commonly used, and we are using all the time, is merge tree. So this is a specific architecture. It is like append-only table engine, but it can do some magic to update some rows or some records in the data sets. It is very efficient, very fast, and you'll see today some examples. This is an example of SQL for creating one of the merge tree structured database. It is nothing to hide. It is our events database, which has more than 100 billion records in that. So it is easy, few strings, event ID, name, application ID, some creation dates when the event occurred, and some properties which are nested structure. You can think about it as a separate table of the data. It is key value, really key value store, which have name and string and value as strings. So when you have some event from some kind of application and categorized by event name, you can put in a nested part, in an array of strings, you can put whatever you need as a key value store. Very easy to use, very easy to implement, and very efficient to store. It will keep only key value elements which you have in the different application systems. So it is flexible, expandable. It is unlimited, really. Engine definition is merge tree. That first part is cluster part, and the partition key. So the created on date will be partition. So everything is partitioned by creation date. There is some syntax in SQL and a ClickHouse, which are able to manipulate with the partitions in a database. It can be, for example, dropped. It can be merged detached from one database and attached and merged to other database, so it is easy to manipulate with that. The bold part, event name and application ID, is a key. So the key part is used to index that data set. It will be very fast to query, something like that. So you are always dealing with the applications connected to your system and some events generated by the name. So it will be very fast to query that. and you all the filtered in a nested data set, it is easy to query something like that. So that's about the database. I will show you something with that more, but this is the basic. So there is nothing more you need to know, just create something like that, push the data inside and query that. But what about representation of the data? Yeah, you never heard about ClickHouse database before today, and you don't know the tool which will be used to query that, except I show you that you have command line client to do that. So we are investigated something around open source space about visualization tools and found this one. There's Apache Zeppelin, part of the Apache organization, and there is a link for that. Somebody using that, Zeppelin in no? No hands? Look at hands, no hands. You should try that. It's very impressive. We'll show you, and you will see today. It is a web-based notebook that enables interactive data analytics. This is an example from our Zeppelin. Few weeks ago, yeah, there is some dates down there. 14 of May, something like that. WannaCry, WannaCrypt, ransomware got the peak. So I will show you the real example of that. From the beginning of the year, ReversingLabs noticed and recognized the WannaCry. So it was a few months ago. There is some small spikes every month. And in April, some more testing of that, and explodes in May, and still running around and trying to get some money for creators. What about Zeppelin more? Yeah, how to use that with a ClickHouse database. Architecture of Zeppelin is simple. It is web application. It is written in some language, running on some web server, and in the front end using Angular, and have a separating backend and front end part. In a backend, using some kind of interpreters. So it is easy to have interpreter for something, for MD, for Angular, for Shell in Linux, for Python, JDBC. There is a huge list of interpreters. So basically and natively, it is connected with the Spark and Scala. Somebody of you are using that. It is a very good platform for Spark and Scala combination. And of course, it can be used for anything else. We are connecting that to JDBC to, for example, Postgre database directly, so it can execute directly from a Zeppelin, Postgre, SQL scripts and represent data on a Zeppelin front end on Angular. And we are trying to use JDBC connection, but we really don't need to use that another layer of complexity by JDBC, because we don't need Java. ClickHouse is a native C++ platform and have a very good command line client. So with Zeppelin, we have a choice. So we will use shell script directly. It will instance in the background, run shell script, make a new instance for your connection, and communicate to ClickHouse database using that shell script, and putting the command like execute in the shell ClickHouse client. There is an example down there. shell echo minus E, that table, I will explain you later what that is. ClickHouse client calling with parameters for the host you are connecting to, make it read-only, and make a query with some limits, and you can display any different formats that set. I will show you that later. This is a full example, so in my presentation you will have everything to test with if you are trying to test by yourself. You will have here examples which are very useful, and it will be easy to try it. You have database structure in earlier shown, and you will have queries here, so you can repeat it by yourself and try. Put some data in, maybe not billions, but maybe a few 100,000 or millions of records on your notebook, and try it. This is a full example. There is some bold parts. This is the connection up there, and there is one very powerful extended SQL syntax, which uses special functions in ClickHouse. That properties dot value is that embedded data set we are using as a key value store inside. Index of properties name, find some hash key there, and in the front is count distinct of that value you are finding, and calculate that as a unique. So that will represent you a unique number of hash keys in that data store or that table you are using. This is another example of representation for our industry-specific feeds, some statistical data. I will show you also that later. Okay, that's combination we are using. That's Zeppelin and ClickHouse. Nothing more to say. I will ask for questions, and after that I will show you something live. Or maybe questions later. Okay. Let's switch. Is this working? Yes. Good. I'm connected to Zeppelin, our development server, directly. I will try to use ClickHouse client on our database. I'm connecting to that. Let's show databases. This is a live system. All the time, we are receiving huge amount of data. I will show you something like select. I didn't prepare anything. I am improvising now. I was thinking to prepare everything, copy paste, and prepare all the environment, some fancy graphs or whatever. But I like to show you this is a database installed. We are loading some data, nothing special. I'm connected directly to that. Started just right now, new session as a client, command line to the database, and nothing copy paste, just my fingers, and show you something. You can interact with me if you have some questions. I will query that directly, no problem. Let's count something from. We have, you saw the show databases. It is similar to MySQL syntax. There is some databases. We have events. Oh, space. Events dot, this is the database. Let's say events underscore 2017 0602. I think it is today. Let's try. What's that? 312 million records calculated in real time in 13 milliseconds, processed 312 million rows, in 23.79 billion rows per second. Anybody know about that numbers? Anybody saw that before? 30 milliseconds for counting something. Impressive. Let's select what we have, how it is look like. Should I do that? My colleagues in the audience, maybe my boss is looking. Okay, let's show some new counts. Yeah. I don't hear you. Oh, yeah. This is 1 day because it is easy to, that's a good point. Let's see, for example, count. Let me see count from events, for example, who knows, all, where created on date is greater or equal to, for example, 2017, 005, 01. Is it really enough? Who asked it? Please read the number. 25,200,000,000 and something for 1 month and something. But if you are not impressed with 2.7 seconds for 1 month, let's see how it will perform from beginning of the year. But you will read the number. What is the number? I mean, applause is okay for 119 billion records. Yes, anybody impressed? I will show you, and I will explain you. This is a single server. There is no cluster. It is 6.9 seconds for counting all the records in that data set. Maybe we can do something like huge counting with end. App ID equal, maybe equal. Okay, like. Anything harder, I cannot imagine. I'm improvising. And I'm brave, I think. Let's say MVP percentage. From the beginning of that. Yeah, let's say 6. We don't have that. Maybe web. No. Okay. Let's say percentage MVP. This will be huge. It cannot finish in real time, no chance. Single server, common hardware. I have more time? No, I don't have more time. But we have a presentation here, and a booth, so you can find me there. 17 seconds, no records. Maybe web. Yeah, it is running 64 million records per second with a query with a like with 2 percentages. If you are using SQL, you know what that means. You cannot use index for that. But this database actually using index also for that. There is a number. It is 18 seconds, single server, 256 gigabytes of RAM, 8 SSD disks, and 4 processors on that. Commonly used hardware, one kind of Dell machine or IBM server, nothing special. 80 seconds, 169 million counting for that stupid query with the like, with the percentages in the beginning and the end. And you're welcome.